Alright guys, so this week we're going to take a look at solving radical equations, and then we're going to do a little review and then take another assessment at the end of this week. So whenever it comes to solving, that's one of my favorite things to do, and that's mainly because we always solve the same way. So you guys will have this proof book. I just added it to the next couple of pages in here, which I think we are on page 91, 92. So again, solving is super nice because we always do the same things when we're trying to solve any sort of equation. First thing we want to think about is get rid of. So we need to be in the get rid of mindset. Like, what am I going to get rid of? Get rid of, get rid of. By doing the opposite. So like if there is addition, I want to get rid of it with subtraction or vice versa. Or if there is multiplication, I want to get rid of it with division or vice versa. There's always one new thing that we have to take a look at, and that's the case here. And then you also, so yeah, we're thinking get rid of, get rid of, get rid of by doing the opposite, but we also need to be thinking in reverse order of operations. So normally I would look for parentheses to do first, then exponents, then multiplication, division, then addition, subtraction, but we need to do the complete opposite here. And so you're looking for that addition and subtraction to get rid of first, then multiplication or division, then exponents, and then parentheses. And we know how to get rid of addition, subtraction, we know how to get rid of multiplication, division. The big question we're going to be looking at today is, how do I get rid of those exponents? And sometimes exponents are kind of hidden behind the fact that they are roots or radicals. So we'll try some in here, and then I'll probably have some for you guys to try on your own. So looking at example 1 here, letter A, I noticed that there's some addition and subtraction right off the bat that I can get rid of. There's nothing scary about that, so I'm just going to add the 8 to the other side. And that's gone, so we have the square root of 5x minus 5 equals 5. But now here's kind of the thing. I also see this minus 5, but it's underneath the root, and so I can't really get to it because the root's in the way. And so at this point, here's where I need to get rid of the root. And so if you have a root, the way to get rid of it is we want to raise each side to the power of that index. So we've talked about this before, because when we had something being squared, we got rid of it by square rooting. And so the same is true here. If I'm square rooting, I square both sides, and it'll get rid of it. And the square root of something squared is just gone, so we're left with 5x minus 5. But over here I gotta do that, like 5 squared, 25. That's not so bad. But then I'm not like in square root land anymore. It's a super easy problem. I can just get x alone by adding the 5. So 5x equals 30. And then dividing the 5. So x is 6. Easy, easy. So the same idea on B, like there are things I can get rid of here first before I have to deal with that root. So I'm going to subtract the 9. So I have 5 cube root 2x equals 20. Now that 5 is being smashed up against that, which is like multiplication, so I can get rid of that as well and divide the 5 away. So cube root 2x equals 4. And now I have to deal with the root, and so this is being cube rooted. So to undo a cube root, we cube it. So they cancel each other out, and you got 2x equals 4 to the third, but I need to do 4 to the third because then I'm going to have to divide that by 2. So like 4 times 4 is 16, times another 4 is 64. Oh my word. Divide by 2. So x is 32. You might notice that in the steps over here there's something we're skipping, and we'll come back to it. Okay, so for part C, there are x's on both sides, which is a little bit stressful. Furthermore, this x is trapped, and so the only thing I really can do is untrap it. So we're going to square both sides to get rid of that square root. But on this side, x squared is just x squared. Like, I don't know how much that is. So the trouble is, like, for a and b, I could then easily solve. Like, once the square root was gone, I could just get x alone. But here, I can't really get the x's alone because there are two of them. And I can bring that one over to the other side, but I can't combine it because they're different. So like x squared plus x doesn't get any smaller than that. And in fact, if you think about it, right now, you are in quadratic land. And if you're in quadratic land, you want to be equal to 0. So I'm actually going to subtract the 90 as well. Because if you are a quadratic trying to solve, you want to be equal to 0, and then you have lots of ways that you can solve. You could do the quadratic formula, which would be no fun. Usually what we tried to do was factor. So I'm thinking, what multiplies to negative 90 and adds to 1? So it multiplies to negative 90 and adds to 1. And I'm pretty sure 10 and 9 is what we want, because that'll multiply to 90. And if I make the 9 negative, I'll get a positive 1 right there. And so we have x plus 10, x minus 9, meaning that my two answers are negative 10 and 9. And this is where that last part comes in, so step 4 right there. And I'm actually going to go outside of the little poof book and do this, because it is important that we check our answers. Because whenever you get two answers, you should always be cautious that maybe one of them isn't real or doesn't really work. And so if I go back to part A and actually check my answer, I need to take the 6 and plug it back into the original equation. So negative 8 plus the square root of 5 times 6 minus 5. And it's a question now. Does that equal negative 3? We're going to see. So 5 times 6 is 30, and then minus the 5 is 25. Square rooted is 5 plus the negative 8 out front. That is negative 3. So that answer is fine. We'll assume that B is also fine. And mainly we can do that because there was only one x to worry about here. We really want to be cautious when we have two answers. So we need to jump to C and kind of check our answers. So let's say first I want to check to see, does x equal 9? So we go back to the top and we're like, okay, 90 minus 9, is that going to be 9? Because that's what the original problem said. And 90 minus 9 is 81, and the square root of that is 9. So that all works out. But now I got to check the other one. So will x be negative 10? So if we plug that in, 90 minus negative 10, does that equal negative 10? And so 90 minus negative 10 is actually going to be 100, and the square root of 100 is 10, not negative 10. And so that one actually does not work out, making that negative guy not an answer. So in general, guys, like, I know that feels like a lot of work to do. Usually you only need to do it if you have two answers, and usually what happens is the negative answer doesn't work. Not always, but usually. So I would suggest starting with the negative one, seeing if that works, and then if it does, check the other one, and if they both do, that can happen, but usually not. Okay, so another type of problem we could have is where you have roots on both sides. We're definitely not going to worry about C, so you can just totally not worry about that. But looking at A and B here, roots on both sides is actually best case scenario, truly, because to get rid of the root, we just need to do the index on both sides as a power, so to the third power to the third power, because they'll straight up just cancel out, and you're just left with the stuff underneath. So 4x minus 9 equals 2x minus 4, and that's a super simple problem. This is not going to be quadratic. I can just get my x's together and get rid of the stuff, so that x will be alone, so we got 2x equals 5, and then divide by 2, so x is 2.5 or 5 over 2. Now you probably should check your answer, because you can always check your answer to really make sure you did everything right, but I'm usually not super hesitant that it's not a real answer unless I get two answers. So same idea here, we can raise it to the fourth power both sides, which just cancels them out. So 3x plus 3 equals 2x. Oh my gosh, I folded that over. What is it? A 7? Yeah. 2x minus 7. Again, this is linear. It's not to the second power anyway. anywhere, so I can just get my x's together, get rid of the things so that x is alone. So we got x equals -10. Oh, that does make me a little worried. Let's check that. So we go back to this, the fourth root of 3 times -10 plus 3. And then is that going to be the same as the fourth root of 2 times -10 minus 7? So on this side, we get -30 plus 3, which is -27, fourth root of that, which is weird because I can't take the fourth root of that. But if I get the same thing on the other side, then it's fine. So -20 minus 7 is -27. So it doesn't equal a real thing, but it does work out that both sides are the same, so it's good. Okay, and then last but not least that we'll try together, and then I'll leave a few for you guys to try. Actually, I'm not going to, because I think I'm going to leave you a worksheet to just do with this, because then we're going to do a review together and then we'll take a test. So just do your notes and then do the homework. Okay, so the last type of thing that we might encounter is no roots, but exponents that are kind of funky exponents. We still want to make sure that we get rid of everything outside of that first. So here, there's kind of nothing outside the parentheses, so we can go straight to the exponent and get rid of it. Now, just like any other fraction, the way that I get rid of a fraction in a power is I do the reciprocal, so 2/3, in the power of this side and in the power of that side. Now 64 right now is to the first power, and when I times it by the 2/3 power, like I did over here, it's just to the 2/3 power. So the reciprocals are nice because like 3 divided by 3 is 1, 2 divided by 2 is 1, your power is 1, and anything to the first power is just that thing. So you're just left with what was in parentheses, the x minus 27. On the other side, however, you need to do that, like 64 to the 2/3 power. And like we talked about last week, I always like to take the root first, so whatever your denominator is your root. So the cube root of 64 is 4, but I still got the 2 there, so that's 16, which goes here. 4 squared is 16. Then I just get x alone, so I add the 27, and x is going to be 43. Okay. Now on B, this one does have some stuff outside your exponent, so I can get rid of the 3 first. So we got 2x plus 12 to the 2/3 power equals 16, because I added the 3 over. And now the thing that I have to get rid of is the exponent. Now if there was a number out front, like I would divide it away, or if there was like a fraction out front, I'd multiply the reciprocal away. But the next thing in line to get rid of is the exponent, and we are always just going to do the reciprocal in both exponents. So 3/2 on both sides. Because that'll cancel it here, because 2 divided by 2 is 1, 3 divided by 3 is 1. Anything to the first power is just that thing, so we're left with 2x plus 12 on that side. But over here we need to evaluate, and so since my denominator is 2, it's like I'm taking the square root, and the square root of 16 is just 4, but the 3 is still there, and then 4 to the 3rd power is just going to be 64. So 4 times 4, 16 times 4, so 64. Then we're just going to solve for x. Super easy now. We subtract our 12 for 52, and then divide by 2, which is 26. Okay. So hopefully solving is a nice cozy feeling because it's the same every time we do it, and yeah, good luck.